Hello everyone, this is Prashanth. Let's continue with the last lecture. In the last lecture, just we have completed what are the importance of HTTP and HTTP protocol. So in the difference between these two also, just we explained in the last lecture in terms of various parameters. It will say how many bits it follows, and what are the protocol, what are the real-time applications in secure and in terms of security, like that. Just we discussed about the differences or comparison between the HTTP and HTTPS we discussed here. So now we move entering into the now the question bank discussion on software defined networking and network function virtualization. So these are the two important topics in module 2. SDN stands for software defined networking, and NFV stands for network function virtualization. So these are the two topics. Just I am going to discussion on the question bank topics. So here these are the some questions will be available on the question bank. So here summarize the following terms, that is M2M, mission to mission value chain, and IoT value chain, and classify differences between IoT and mission to mission. Classify the differences between software defined networking and network function virtualization, and list out the limitations of simple SNMP, simple network management protocol, with suitable examples. Classify the differences between IoT and mission to mission. So repeat the question. So these are the some question bank questions will be discussed in this lecture. So here before that, first start with software defined networking. So what are the main contents of software defined networking here? The introduction point, limitations of conventional network architecture. So before software defined networking, before going to define or before implement software defined networking, first we have to know the what are the limitations, what are the process, or what are the specifications of conventional network architecture. So is there any limitations or a disadvantage? To overcome that, just we go for that is improved version, that is software defined networking. So that's why limitations of conventional network architecture, and what are the key elements of software defined networking, components, key elements, components, and different models of software defined networking architecture, and last advantages and disadvantages of software defined networking. So here the start with what is the meaning of first software defined networking. So what are the components, what are the main two terms involved to define the software defined networking with a clear manner. So here the software defined networking, which is a network architecture approach. So it is just networking architecture approach. It enables to control and manage of the network using software application. So here, with the help of software application, we can control the network and manage the entire thing which is available in the network. So the software defined networking, behavior of the entire network, and it is devices to programmed in a centrally controlled manager through the software applications using open application programming interface. So here we have two terms, data plane and control plane. These are the two terms, very very important terms. So here the control plane and data plane. So here in conventional, just it is traditional. This is in software defined networking. So here each control plane having each data plane having control plane 1, 2, and 3. So here we have 3 data planes, respectively we 3 control plane. So in software defined networking, so here just it maintains centralized control plane in order to control all the data planes which are available in the network. So that is the biggest advantage as a most advantage of software defined networking. So it may in place of different control plane, just it maintains centralized control plane. That is the one of the advantage or application of software defined networking. So it maintains the centralized control plane. Centralized controller plane. So here this is the just architecture view of traditional network architecture and traditional software defined networking. So what is control plane, what is data plane? Just we have to know that all the activities involving as well as resulting from the data packets sent by the end user belong to this plane. This include forwarding up for packets, segmentation and reassembly of data, replication of packets for multicasting purpose. So these are the three terms involved in data plane and control plane. So here all the activities necessary to perform data plane activities but do not involve end user data packets belong to this plane. In other words, this is the brain of the network. The brain of the network is control plane. So it can maintain the for example these 5 fingers 1 2 3 4 5. So for these 5 fingers, just the center point is this part here. So from this part only the finger 1, finger 2, finger 3, just it can operate or it can move apart from this here only. So this is the just control plane. These are the different data planes. So this is the centralized control plane. Just you assume like that only. So here the purpose of control plane is making routing table and setting packet handling policies. So this is about the what is control plane and what is data plane. So here software defined networking architecture that separates the control plane from the data plane and centralizes the network controller. That is okay. So in the conventional network architecture and control plane, data plane are coupled. Control plane is the part of the network that carries the signaling and routing message traffic, while the data plane is the part of the network that carries the payload data traffic. So this is the just separation of control plane from the data plane. This is the SDN controller, control plane logic. Control plane, control plane. Just it can separate switch1, switch2, switch3. Can separate the control plane from the data plane. Next, control separation has many benefits. So as we already know, as compared with the traditional network architecture, just we know the only we work on the up to only single point, that is it is the separation of control plane from the data plane in the software defined networking. That is the term. So for that, just we have so many benefits like central management and lightweight network equipment. So the complexity of the network hardware part of the network also will be reduced based on separation of the control plane from the data plane, and network virtualization and everything will be will be operated through the just we can increase the virtualization process also. SDN control and real-time example like that. So here these are the control plane has many benefits like central management, lightweight network equipments, network virtualization. So some of the limitations of conventional network. So to overcome these three, just we go for software defined networking. Just that is the main important term. So here the management overhead. Network manager find increasingly difficult to manage multiple network devices and interface from multiple vendors, and upgrade of network requires configuration changes in multiple devices. So this is the about management overhead. And limited scalability. So the scalability also limited as compared with the other technique. That is virtualization technique used in cloud computing environments has increased the number of virtual hosts requiring network access. That is the limited scalability. And in the complex network devices, the conventional networks are getting increasingly complex with more protocols being implemented to improve link speeds and reliability. So these are the limitations of conventional network architecture. So next to key elements of software defined networking here. The key elements coming to key elements of SDN: centralized network control, programmable open application programming interface, and a standard communication interface. So these are the three key elements of software defined networking. So next is what are the components of software defined networking. So here SDN applications, SDN controller, and SDN network devices. What is application? Just applications relay request or networks through the SDN controller using API, and SDN controller collects the information from hardware, sends the information to the applications. So next, the network device help in the forwarding and data processing of the particular task depends on the application. So these are the some components of software defined networking, like SDN applications, SDN controller, and SDN networking devices. So next, why SDN is important to build the some real-time IoT projects. So here, better network connectivity. So just it can provide better network connectivity from the centralized network control plan. So here SDN provide very better connectivity for sales, services, and internal communications. So SDN also helps in faster data sharing. Next, the better develop deployment of application. So in order to develop the some IoT real-time project, it is useful to do that type of task. Deployment of new applications, services, many business models can be speed up using software defined networking. So that is the second important point. And better security. Some security protocols will be strong as compared with the traditional network architecture. So here it is provide better visibility throughout the network. Operators can create separate zones for devices that require different levels of security. SDN networks give more freedom to operators. So that is the third one. And better control with high speed. Software defined networking provides better speed than other networking types by applying an open standard software based controller. So these are the some why the important points regarding software defined networking, like better it can provide better network connectivity, and it can develop the different types of applications based on the requirement. It can provide better security protocol and better control with the high speed of the processing of the data. So these are the some important points. So here next we have network function virtualization as the part of question bank discussion on the SDN and network function virtualization. So here network function virtualization, here NFV stands for network function virtualization, NFV, and NFV is the concept of replacing dedicated network such as routers and firewalls with software running on general purpose CPUs and virtual machines operating on the standard. So it can provide the infrastructure on which SDN can run. So that is the relationship between SDN and NFV is. So this is the third point. It can provide the infrastructure on which device software defined can run. So NFV SDN are mutually beneficial to each other, but not dependent on the each one. So these are the just some introduction points regarding network function virtualization. So here what is network function virtualization? It is a network architecture concept that leverages the IT virtualization technologies to virtualize entire classes of network node functions into building blocks that may connect to and create the deliver communication services. Compulsory, the network function virtualization, it can provide the certain infrastructure, the applications which based on that net software defined networking. It can provide virtual infrastructure to the existing network. So that is the main point you have to remember. And virtualization network or VNF is implemented with one or more virtual machines or containers running different software and process on the top of commercial off the shelf high volume servers, switches, and storage devices, instead of having custom hardware appliances for each network function, thereby avoiding vendor lock-in period. So this is the some introduction points of network function virtualization. And with the help of network function virtualization, it becomes possible to separate communication services from the specialized hardware like routers and firewalls. Eliminates the need for buying new hardware. Network operations can offer new services on demand. So everything is going on virtually, so there is no need of purchase any hardware components to implement any network. So that is the main purpose here. With this, it is possible to deploy the network components in a matter of hours as opposed to months as with conventional networking. So furthermore, the virtualized services can run on less expensive and generic servers. So this is the some introduction points of network function virtualization. So this is the some more elaboration of introduction points of network function virtualization. It is allows separation of communication services from dedicated hardwares or such as routers and firewalls, we already know. So here also the virtualized servers can run on less expensive generic servers instead of the proprietary hardware. So additional reasons to use network function virtualization include here pay as you go, fewer appliances and scalability in order to improve the scalability. So pay as you go nothing but it can reduce the cost because business only pay only for what they need. So for example here 12 GB of data I want to use, for that amount only just you have to pay some amount whatever just for 12 GB of amount, for example 4,000 5,000 like that, whatever just you use you have to pay for that amount only. So that is pay as you go important point. And if your appliances because of network function virtualization, NFVs and virtual machines instead of the physical machine. So fewer appliances are necessary and operational cost are lower also. So some devices are compulsory to run on the hardware part only, that is okay. That is in the place of hardware just we can use virtual machines. So compulsory the cost will be reduced. So that is the fewer appliances to developing the some fewer appliances virtually. And scalability also, scaling the network architecture with virtual machines is faster and easier. It does not require any purchasing of hardware. So everything is going on virtual mode. So there is no need of purchasing hardware components like. So these are the some additional reason. So here some key elements of virtual NFV, virtualized network function VNF, and network infrastructure management, automation, and network orchestration. Here VNFs are network functions that can be implemented as software and deployed on NFVI, network function virtualization infrastructure. So here the examples include firewalls, software defined wide area network, routing, and quality of services, that is QoS. So NFV infrastructure, the NFVI includes all of the software and hardware that make up the environment into which NFVs are deployed. So if NFVI spans multiple sites, the network connecting them considered part of the NFVI. The next management automation and network orchestration, it is shortly MANO. NFV MANO performs management and orchestration of VNS within the NFV network. So these are the some key elements of network function virtualization, virtualized network function infrastructure, and management automation network architecture. So these are the key elements. And service chaining, software defined network branch, and SD-WAN network monitoring and security. So these are the some key elements of NFV. So this is the just architecture view of NFV. So this is the part of these three parts. So here under virtualization layer we have computer hardware, storage hardware, network hardware. These are the physical resources. Just it is transformed into the virtualization layer, virtual computing, virtual storage, and virtual network. So based on that, just we have under service and VNF infrastructure description, EMS1, VNF1, ENS2, 2, EMS3, VNF3, like that. So here this is the network management and orchestration, the right side part. So orchestra and VNF manager, virtualized infrastructure manager. So this is the complete view. So this symbol indicates execution reference points. So this denotes other reference points. The plus symbol denotes main NFV reference point, like that. So this is the complete architecture of NFV and different models of software defined networking here. After complete the introduction points up to now, just we have completed the introduction points of SDN and NFV. What are the key elements, what are the types, what are the features, what are the advantages of SDN and NFV. So now we move to the different models of software defined networking. OpenSDI, API SDI, and hypervisor based overlay network, hybrid mode software defined networking. It combines SDN and traditional networking, allowing the optimal protocol to be assigned for each type of traffic, and hybrid SDN is often used the based on the approach. So let's start with the OpenSDN. So here OpenSDN uses open protocols to control the virtual physical devices responsible for routing and data packets. So here the SDN applications define the controller part. Under the control part, just it is open flow, and it is open flow network device, and network device. So this is the just block diagram of Open SDN. Next to Open API SDN, application programming interfaces software defined networking. It is also called as a southbound API also. To control the flow of data and from each device. So here hybrid networking is a combination of traditional networking with software defined networking in one networking to supporting different types of function on a network. And SDN via hypervisor. So here by using hypervisor, just we can connect the network devices from the controller part. The based upon that, just we have the entire information came from the SDN application to connect to the network devices. So hypervisor is used to connect to the edge devices also. So this is the part. So this is the SDN via hypervisor based overlay network. And architecture, typically SDN architecture consists of 3 layers here. Very important. One is the application layer, control layer, and infrastructure layer. Application layer for the purpose of routing, load balancing, and etc. Northbound UPIs here, the control plane, control layer, SDN controller. Southbound APIs, infrastructure layer, physical switches, and data plane. So this is the just architecture of 3 layers here. Application layer, under application layer we have done different activities, control layer and infrastructure layer. So next, software defined networking architecture. So there are many approaches to lead the development of today's software defined networking. So here forces, 4D approach, and ETH. So these are the 3 advanced approaches to explain the software defined networking. So here forces, nothing but forwarding and control element separation. The idea of separation of data plane, forwarding element, and control plane was first processed by forces only. That's why it is called forwarding and control element separation. It can be implemented in 2 ways: control element, forwarding element, and forwarding element. So the forwarding element and control plane are located within the same network. That is the first way. And the control element is taken of the device and placed in a separate system. That is the second way to implement the forces. And 4D approach. 4D is nothing but D. 4D is like decision, decimation, discovery, and data. With the help of 3 levels here: network level objectives, network wide view, and direction controller. So here this is the centralized controller part: decision, discovery, decimation, and data. With the help of network objective, so it connected to the network devices to finally decimate the function. So this is the 4D approach: decision, decimation, discovery, and data. So it is the last one, ethane. So it specifies the network level access to access of users, which is defined by network administration. Ethane is the exact forerunner of software defined networking, like that. So it is the principles: having high level policy should inspect the network. That is the first principle. The second one, routing should follow high level policies. That is the second one. And there should be a connection between packets and their origin in the network. So this is the ethane controller. For this, net flow of with the help of flow and entries, network devices, bindings, it maintain topology, some registration pattern policies. So this is the Ethan architecture, one of the modern method to define the software defined networking. So these are the some references I used for this lecture. This is the question bank on network function virtualization and software defined networking. So these are the two important topics in order to provide the virtual infrastructure. Just we use network function virtualization. The software defined networking, just it can deal with the hardware part. Just you can separate the control plane from the each data plane. It maintain the some centralized control plane. And network function virtualization, what they work on software defined networking. For that, it can provide certain infrastructure to operate virtually. So that is the main concept of network function virtualization and software defined networking. It is very, very important to know. So this is the part. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.